Paul Callaghan of OLEOLOGY, who's going to talk to us about deep dive into decommissioning challenges, including mercury removal. Welcome, Paul, from OLEOLOGY.
Good morning, thank you. OLEOLOGY is an Australian-based company that's been in operation for about 22 years, based out of Perth. We now have offices in Brisbane and on the East Coast and in KL. OLEOLOGY's developed quite a knowledge in fluid space for contaminant treatment, removal, coalescing of oil, various other specialised innovative engineering approaches to traditional problems. We've taken that information and set up a separate organisation so that we can be somewhat consulting, technology agnostic, and able to deal with the clients on what they require. So our consulting agency is now about engineering and innovations to assist clients in overcoming traditional problems. So for the decommissioning space, we're looking at a range of problems that begin with the short list that I've got on the screen at the present stage. These can be attributed in different ways to different clients and different locations. The range and priority will alter depending upon the regulators, the client operations, their locations, the costs, the existing equipment. There's a range of operational necessities. Importantly about that, what we really need to do, as far as we're concerned, is bring that innovative engineering expertise that we have developed into the area of the process to treat. The process to treat can be one where we do the traditional engineering activity, which is really just get a bigger hammer. We develop something that we've traditionally done and just used more evolution to bring about a solution. We tend not to do that. We believe that we're in a situation now where we need to be more cognizant of the amount of waste that we generate, the amount of energy that we consume, how it best impacts ESG and shareholder value. So in order to do that correctly, we've come up with a way which is really the analysis of desired process outcome. And that's the core of the way that we attack the problems that exist at present, those that are likely to come up in the future that we can perceive as being an outcome. In many instances, in our part of the industry where we're dealing with fluid and fluid contamination, discharges to the environment, to air, to land, to water, to fresh water, to salt water, the regulations are continually changing. Our understanding and our work has shown that as the laboratories are able to assess to a lower level of detection, the regulation has followed that. Our work with the US EPA has shown that the US EPA, as a forerunner in our world of regulation, is willing to put in new and tighter regulations based around the technology that's available and proven, but also the ability to assess that through laboratory standards. The decommissioning process and the challenges that are there, we'll just look at one of those, and really 15 minutes is just enough to scrape across the top. So we'll look at the process to treat, those areas where we're able to develop with the client the opportunities for them. And by that I mean we take, starting at the top of the circle, that empathetic position. We need to align our objectives with that of the client. And that might be any of the 11 items that were initially on the first few slides. We need to understand where their current position is. From that, and set a common alignment between ourselves, potentially other contractors that might be involved in the assessment. We look at what is feasible. We undertake a gap analysis. What existing equipment is in place that would be pertinent to the ongoing use and the reductions of waste, the improvement of the assets, all leading towards that point of decommissioning. The design and the solutions that we innovate and engineer into our systems are then brought into the discussion. From that, we're able to model full-scale water treatment systems, assess cost, operating cost, waste, logistics, the HS&E implications of it, and we'll begin to talk about the use of mercury as a contaminant and a captured contaminant, or we look at potentially what might become of norms. Every piece of equipment that is then used for the decontamination also then has to be assessed for what happens to it post the activity that's undertaken with the client. That enables us to give us a test regime. Everything that we do is able to be scaled, and it's scaled directly. So we can take from lab scale up to full-scale implication for installation at client site, and we can test accordingly, knowing the outcome that we will get in our test facility will be the same as that which will be achieved on site. That gives very good confidence for both ourselves and the client that the full-scale implementation will in fact achieve the outcome. Importantly, when we talk about mercury and mercury removal and reduction, we're able to speciate. That is very important. In gas production, mercury is generally in the one species, which is elemental. Droplet size becomes very important, and we're able to deal with that in gas production. And that's a very innovative way, which is significantly less in both size, weight, interchangeability, change out frequency, we reduce the HS&E. That's relatively simple for the type of technology that we have. Part of that technology is then able to be used in other fluid treatment. So if we're looking at water treatment, for instance, because we're using water as a medium for decontaminating pipeline assets, etc., then it's very important to understand mercury in its species. Mercury species, as it weathers, changes, and we have a small amount of elemental. Principally, we have colloidal and ionic in the species. They're mixed in with other co-contaminants. Those co-contaminants provide the difficulty for removal. So importantly, as part of our testing and trialling, we're able to speciate what that mercury form is, so that in the assessment of the type of equipment that might be required, we correctly speciate and set up the filtering, coalescing or mercury removal such that water is able to be reused in the process of cleaning. It's a very important part of reducing the waste. All this leads to a range of desired outcomes. And so if we start talking about the decontamination, we need to understand, is the asset to be repurposed? Is it going to be abandoned? Is it going to be transformed, taken away, melted down? What implications do these have? What implications does it have for the health and safety of those activities undertaken at site? The logistics become really important. Are we dealing with something that's onshore, something that's offshore? How is the HS&E for the operators taken into account in that particular type of operation? Most importantly, when you consider the first two quadrants of discussion here, how are the logistics going to affect the overall operation? I mean, some of the budgets and blowouts that we saw in the first presentation this morning, they're really the important assets. Casting the net very wide and understanding the full cost of the operation really does make a very big difference when you're looking at remote assets and how the logistics are going to interplay, particularly when removing and utilising waste transport. All of this then comes to end-of-life investment. Is it a total cost? How does it affect shareholder value? How does the value to the shareholders become realised in the full state of what is this going to be in future? We've already seen in Australia examples of stranded assets that are a very large cost to be dealt with as yet. The planning and approval process becomes a very difficult one as well. The number of agencies that need to be dealt with in order to be able to prove the efficacy of the treatment, the robustness of it, that all becomes part of our purview. That becomes part of the considerations for the desired outcomes. And without delving through each one of those individually, we just need to look at that particular area of the decontamination. But all parts of it, and I mean all parts of it, from what you're trying to do with just the minimum amount of water treatment, for instance, if you're decontaminating a particular asset, has to be considered overall. For us, if we just look at the decontamination and look down these very individual areas of contaminant, the decontamination for the assets are technologies that are innovative and are available now. We don't have to deal with large amounts of waste. We are able to handle a range of contaminants of concern right now. Without putting too fine a point on it, it's important to understand that these are available here in Australia. There's new technology that is at our fingertips now. It takes a discussion to bring about the changes to affect lower cost, safer decontamination with less emissions. So we can achieve these desired outcomes for the process. They are here and available in Australia. They're available in some of the parts elsewhere in the world, and we've been able to help some of our partners over in the US in developing these things, which is great for us. As I said, OLEOLOGY is now in two parts: systems and servicing, which is really the installation and hardware, and the consulting division to help align with technology agnostic people that have got a large amount of experience in the industry over many years to provide those systems to our clients. Thank you.
Thank you very much indeed, Paul. And we do have time for questions if people have got questions.
Hi, Brian Linshaw's Decom. Some of the challenges that we have just now is not actually knowing the level of contamination until the item has been removed and is onshore. And then it's trying to work out the end state of that component that's to be cleaned and what, let's say, a smelter will accept. And we're in this kind of grey area where we're trying to come up with the cleaning costs, but we don't know the parameters at the start and we're not sure the parameters at the end. Have you got any advice on what we can do to try and close that gap?
Brian, my advice would be come and talk to us, but without being too glib about it, one of the things that we've discovered through the process that we have, and we can relate it to other highly difficult to remove contaminants, say from a process which is utilising water for decontamination. And you could relate that to a PFAS example. Highly soluble, doesn't break down, half-life of 40 to 90 years, and it ranges in its concentration significantly. So the process is two stages really: coalescing that and removing the bulk of it, and then via a process of gradual reduction, removing both co-contaminants, which add to service cost, and also removing the targeted contaminant. We get to the point where we're polishing, we're almost at a uniform state. So that homogeneous state that we've now achieved by coalescing and gradual reduction by filtration gives us the ability to nominate the state at which we wish to deliver as an endpoint. So what we've done and what we've found is that, as relates again to PFAS, that the NEMP2 requirements, which is stipulated at either 80% or 95% or 99% of reduction, the cost difference for us in utilising that same system where we're reducing gradually contaminants and co-contaminants means there's very little cost for us in the final production of the discharge water. Between 95% and 99%, and there's significant difference in there, and metals is one of those same similar areas, there's very little cost difference in ongoing. It would be very helpful for either the regulators or the smelter or others to come to us and say, this is exactly what we want. but it tends to be the other way around. The onus remains with the decontamination group to say what they can do, and then potentially we will or won't accept it at the time it gets to the gate or at the time the application gets to the regulator for approval. So we're batting on the side of safety and saying, let's remove more and get it to a stage where we're somewhat future-proofing ourselves. We don't want to be in a position where we've got a liability in future because not enough was taken out.
Thank you very much indeed. Very interesting perspectives. Thank you for joining me.